Now suppose we'd like to ask the question, how do we find the surface area of one of these parametric surfaces? Well, we can use a technique similar to one we used in Calc 1 for computing integrals. We break it up into little tiny pieces and take that limit. So let's do that. Suppose I had a surface, sort of like this one. And suppose these are the curves through that surface. So these would be the curves where you fix either u or v and then move along the other one. Suppose this is a point we want to look at. Now it has our two vectors. Suppose this one is RU, just like in the last section, and this is our RV. Now recall we can find the area of this parallelogram by taking the magnitude of the cross product. So suppose we index that point to be the ith point on our surface. Then delta Sij is the magnitude of the cross product of these guys. U times the delta U delta V. Now, the area of this surface, A of S, is going to be the limit as these tiles become smaller and smaller and smaller, right? Because this isn't quite 100% accurate, because there will be some deviation from the plane, or the surface. But if we take the limit, that'll all get ironed out. So A of S is the limit as m and n approach infinity of the sum I equals 1 to m, sum j equals 1 to n of delta Sij, which according to that was limit n approach infinity, sum I equals 1 m, sum j equals 1 n of Ru cross Rv, its magnitude times delta U delta V. Now this is equal to the limit. Or in the limit, this is equal to the integral over the domain of ds. Now ds just so happens to be equal to this part. So this is integral magnitude of Ru cross Rv du dv. So the takeaway point here is that ds is equal to magnitude of Ru cross Rv du dv. And you can use whatever techniques you want to solve this integral. But that will depend on a case-by-case scenario.